Hi everyone, and welcome to this, my lesson on tangents and normals. Yes, my name is Darren from Maths Guru. Where? Maths Guru, of course, that little corner of the internet I call mine, where all of these lessons are sort of easily accessible, downloadable lesson notes, VCAA exam questions, and so much more. What are we looking at this lesson? Well, of course, the learning objectives are behind me. Understand the difference between a tangent and a normal, be able to find the gradient of the tangent to a curve, the gradient of the normal to a curve, and be able to apply this understanding to a range of different questions. Okay, sounds fairly simple. Now, this is sort of the first lesson of this section of the course, but it's building on all of the differentiation work we've done before. Now, we know how to differentiate. You multiply by the power, take one off the power. We know how to do it from first principles. We know sort of why we're doing it, because it's going to find the gradient of the tangent at a normal. But what if we want to find the equation of a tangent at a normal? Well, a tangent at a normal is basically going to be a straight line. We already know this. It was built up from the first principle stuff we did a long time ago, right? So we know that we have y minus y1 equals mx minus x1. Okay. I know lots of you out there go, no. But what about y equals mx plus c? Look, okay, you can use that if you want to. I personally don't like it. I like the idea that this here requires one coordinate and one gradient. And by differentiating and substituting in an x value, I'm going to get a gradient anyway. Okay, happy with all of that? Okay, so that's sort of a recap. Now, what is a tangent? Again, we've done this before when we did the differentiation from first principles. We choose 2 points and we drew a line between them. And we said, what happens when that line gets closer and closer and closer and closer to a specific point? Well, what happens is if that was the point there, that is a tangent to that point. Now, again, I had to do this at school, and I'm still in therapy for this by pencil and paper methods. Not only did we have to try and draw this graph here accurately, what? Computers? We didn't have computers when I were at school. We had slits. Anyway, and so basically when we had to draw this by hand, and you can imagine how not accurate that was. We used to have to hold up a piece of paper level to our eyes to see how accurate it was. And if it had any wobbles in it, we had to rub it out and start again. That was a whole lesson of fun. Not having drawn it, then what we would do is we'd be like, oh, okay, well, I'm going to find this point here. And now I had to try and draw some sort of a straight line with a ruler so that, oh, see, I can't even do it with electricity. If I can possibly move this around, is that a tangent? No, not at the moment. Why? Because it's crossing through the lines. We have to rub it out. And then having finally drawn this thing on, we would then have to find 2 points accurately to find the gradient. Now, I swear to you, I'm still in therapy because of that. But now we've got differentiation. Differentiation makes life a lot easier because, well, we can find the gradient of a tangent at a point simply by differentiating. Okay, so let's look at this example about finding the gradient of the tangent to a point. We can do that. Find the equation of the tangent, all right? So we're going to find the equation of the tangent. So that means we're going to use y minus y1 equals mx minus x1 somewhere in here. All right, okay, find the equation of the tangent to the curve y equals, so y dashed is going to give me equal to 3x squared. Simply differentiate. Half times 2 is going to be 1 plus x. Now we know that x is equal to 1. So we know that y dashed, which is the same as m, is going to be 3 lots of 1 squared plus 1, which is going to give me 4. So there's my m value. It is 4. So now, if I can do this, I've got y minus, y1 I don't know at the moment, m is 4, x minus x1. Well, I've got an x1, which is given by 1. Again, this is my value of x1. How am I going to find my value of y1? Well, again, if I know x is 1 here, I can substitute it in there and hopefully get the right answer. So y is going to be equal to 1 cubed plus a half times 1 squared. 1 cubed is 1. 1 squared is 1 plus a half is going to give me 3 on 2. So there is 3 on 2. And I've now pretty much done. Yes? Well, no, because I've got to simplify it. Now, what I tend to do in this situation is because I don't like fractions, I actually multiply everything by that 2 to get rid of the half. So I'm going to multiply absolutely everything by 2 to give me 2y minus 3 is 8 lots of x minus 1. And again, lots of people here make silly mistakes because of the fractions or because of the fact that they don't realize that this 2 here only multiplies the 4, the 2 here multiplies the y, the 3 stays on its own. And again, the number of students I see who sort of trip up on this stuff because the basics of your algebra is not particularly great, that's the stuff you need to concentrate on. So many people say to me, oh, I need a private tutor to help with methods. No, you don't. You need a private tutor to help you with year 9 and 10 algebra. That's it. Smash that algebra. The rest of methods becomes trivial. I promise you, because you'll probably spend more time fighting with algebra than you will with the methods. Right, so 2y minus 3 equals 8x minus 8. Add 3 to both sides. To get rid of that, it gives me 8x minus 5. And now I'm going to divide by 2 because I can do that. And there we go. There is my equation of my tangent. Now, drawing the equation of the normal to a point. Now, again, to be able to find the equation of a normal, and a normal is a right angle to a tangent. It is a right angle. It is drawn perpendicular, probably should have said that, to the tangent, which means you've got to find the tangent first. So again, if I had this point here and I roughly try and join that there, is that going to work? Nope. So let's try that one again. See if my electricity will do a good thing there. There we go. So again, assuming that was anywhere near a tangent to the line, all right, once I found the gradient of that tangent, I can thereby find the gradient of the normal, which will cut through that point. And if I could try and move this over with my electricity, right, we know that that here, this here, oh, this here is a right angle. It is 90 degrees. It is perpendicular. Well, if I know this gradient, how do I find this gradient? Well, again, from way, way back when, we know that if we take the gradient of the tangent and multiply it by something that is perpendicular, all right, or if you take two lines that are perpendicular to each other and multiply the two gradients together, you will always get -1. I like to think of it as this, as to find the gradient of the normal, do -1 on the gradient of the tangent. And again, what that actually means is when you do 1 on something, you're actually taking the reciprocal. So you take the reciprocal and multiply by -1. So for example, if the gradient here was a half, he says writing it in a dreadful color, then the gradient of this would be take the half, flip it upside down, so that's 2/1, which is 2, and then inverse the sign negative. And again, it makes sense that that gradient there would have to be negative. If you ended up with a non-negative value and the gradient obviously is sloping down that way, it doesn't make a lot of sense, and you probably have made a mistake somewhere. Okay, right. So now let's practice our finding the equation of a normal to a point, right? So we've got to find the equation. It's always important to highlight the key words here. So I'm going to need y minus y1 equals mx minus x1 again. All right, to the curve. Now, we can't find the equation of the normal until we have something to do with the tangent, all right? So remember, we've got to find the gradient of the tangent first before we can find the gradient of the normal. So we can do that. Y is equal to, so y dashed is equal to 3x squared minus 4x. Now again, they've given me way too much information here. I don't need, for the moment, that -1. Right? I only need to know my x value. So in this situation, x equals 1. So y dash becomes 3 lots of 1 squared minus 4 lots of 1. That's 1, so that's 3 minus 4 is -1. Now that's my m value, remember? That's my gradient of my normal. But I don't want the gradient of my normal. I want the, sorry, that's the gradient of my tangent. I want the gradient of my normal. So what I'm now going to do is I'm going to do -1 divided by that value there. Oh, well, -1 divided by 1 is going to give me 1. So I now know that the gradient of my normal, right, is equal to 1. So we got y minus y1. What's my y1? Well, now we need that y value. You may turn around and say, but hold on a moment. Is it the same point? Yes, because we have found the gradient at a particular point. Right? That point that I'm highlighting there is where we found the gradient, 1 minus 1. The normal passes through that point as well. Okay, so y minus y1, which is -1. Notice I use brackets because the brain sort of trips over these minus signs, is equal to the gradient of 1, x minus x1, which is 1. So it's going to be y plus 1 is x minus 1. And so in that situation, y, yeah, that was terrible. And so in that situation, y is equal to x minus 2, ka-ching, and there is the gradient of my normal. Another example, find the equation of the tangent to the curve with equation that. And again, VCAA know that people hate fractions. They know that people trip over on fractions. So again, you want a tutor, get a tutor to smash fractions with you. That will be way more beneficial than getting them to pre-teach you this content. Right, so y is equal to that one. The equation of the tangent, I'm going to highlight tangent so I remember. So y dash is going to be equal to 3 on 2. So I'm going to multiply it by my power and take 1 away from my power. 3 halves minus 2 halves is going to give me 1 half. So there's a half. Minus 4 times a half is going to give me 2x to the minus a half. So there we go. At the point on the graph where x equals 4. So we know where x is equal to 4. So we want y dashed is equal to 3 on 2 times 4 to the power of a half minus 2 lots of 4 to the power of minus a half. And again, because my index stuff, I know it inside out and backwards. It's another part of the course that people trip over. That is nothing more than the same as a square root. So we want the square root of 4, which is 2. So I now know that that is actually 2. So we do that in a different color. So we know that is 2. That there is actually going to be 1 on the square root of 4, which is a half. That 2 cancels with that 2 there. So realistically now that just leaves me with 3 minus 2's going to 2 one time, 1, which simply gives me 2. Notice how something really, really disgusting turned into something relatively easy simply because we knew our index laws and I knew how to use fractions and cancelling down. All right, so the equation of the tangent. So therefore we want y minus y1 equals mx minus x1. So y minus, do I know what y1 is? No, I've got to find it. Okay, how are we going to find it? Well, they give me an x value. I can find a y value at that point. Now, without trying to bore you here, the y value when that is put in is actually 0. And I say bore you. If you don't believe me, just put it in because you, oh, I'm going to do it. So what have we got? We've got 4 to the power of 3 on 2 minus 4 lots of 4 to the power of a half. Well, we've already said that we know 4 to the power of a half is 2, and 4 times 2 is 8. Now, what on earth is 4 to the power of 3 on 2? Well, again, that's the same as 4 to the power of a half cubed. And again, basics index laws. Yes, 3 times a half is 3 and a half. So I can split that 3 on a half, 3 halves into 3 lots of a half. Well, 4 to the power of half is 2, and 2 cubed is once again 8, and 8 take away 8 is 0. Now, of course, you can download all these summary notes, and if you can subscribe to my YouTube channel, that would be massive. Nobody watches math videos. If you find this useful, then please let me know by just leaving a comment and subscribing, and obviously liking the video. Right, so that's 0. My gradient we worked out was 2x minus x1, which is 4, gives me y is equal to 2x minus 8. Ka-ching, there's the right answer. Now, of course, this is a CAS course. Can't we do this using the CAS? Yes, we can. Absolutely can. So I'm going to bring up my CAS, he said. And where is my CAS? There we go. Bring up my CAS. Hit menu. Now, obviously, for the ClassPad users, I'm so sorry I'm using the TI Inspire. Again, the functionality is fairly similar for your calculator. Hopefully, you can sort of find the function on there. So what do we want to do? We're going to find the tangent to the curve. So I go menu, calculus, and basically you'll notice I've got tangent line and normal line. And then I'm going to hit tangent line and I'm like, okay, well, what do I put in? Well, if ever you're not sure, you can actually hit the book icon. And then if I hit T on my calculator, and I hit P for some reason, if I hit T, he says, if I go down to T and I click on tangent line, it'll actually give me what I've got to do. So I've got to have put 3 things in: an expression, what my variable is, and what my value is. Okay, so, and again, if you weren't sure how to get all of that on, just click the up and down arrow there. Right, hitting escape. So tangent line was my expression. Well, in this question, my expression is y to the power of 3 on 2. No, it isn't, again. And you don't need to put the y equals x to the power of 3 on 2 minus 4 times x to the power of a half. And then a comma, you have to say what your variable is, comma. and what the value is. So we want it basically when x equals 4. Hit enter, and oh my goodness, 2x minus 8. So much easier than doing it by hand. What if I wanted the normal to that? Basically, once again, I'm going to go normal, calculus, normal line. Oh, I don't know what the can't think of that. Variable, expression, variable, and point. Okay, well, again, so in which case I'm just going to copy all of that down. Copy it all the way down, hit enter, and there we go. That's your equation of your normal at the point. Okay, now moving on to another example. This is method 3 and 4, trig, 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 and more trig. So what have we got here? We've got to find the equation of the tangent. So we want the tangent. So I'm going to write y minus y1 equals mx minus x1, just to help me, of the graph of y equals sine x at the point where x equals pi on 3. Okay, so the first thing we need to do is do y dashed. Sine goes to cos. So cos x. So the gradient when x equals pi on 3 is the cosine of pi on 3. Okay, what's the cosine of pi on 3? Well, if all else fails, I can draw my right angle triangle here, and that's pi on 6, and that's pi on 3, and that's a right angle, and that's 1, 2, and root 3. So on the cosine, which is caught a herring, which is a half. And a lot of people now are screaming at me going, yeah, but you can remember this. Yes, okay, but there are other ways of doing it if you need to. So my gradient is equal to a half. So that means I now know my gradient. I got my value of x1. I need to find my value of y1. How am I going to do that? Well, I'm simply going to substitute pi on 3 into here. So therefore, we want my y value is equal to the sine of pi on 3. So sine of pi on 3. Here's pi on 3. Silly. Old Harry. So root 3 on 2. And there we go. So now we've got them. Therefore, he says we've got y minus root 3 on 2 equals my gradient, which is a half of x minus x1, which is pi on 3. Now, in that situation, I can multiply everything through by 2 to get rid of these ones here. So that's going to give me 2y minus root 3 is equal to x minus pi on 3. Add root 3 to both sides gives me 2y is equal to x minus pi on 3 plus root 3, and divide everything by 2 is going to give me y is equal to x on 2 minus pi on 6 plus root 3 on 2. And so sorry that I seem to run out of space there. It's not particularly user-friendly. Quite long, this question, really. But there we go. That is my correct answer. And again, if I wanted to, I could have put that in my calculator, and lo and behold, out would have come the answer. Find the equations of the tangent and the normal to the curve of the graph of y equals minus cosine of x. Well, again, I'm going to start it off by pencil and paper, because we now know that y dashed equals sine goes to cos, cos goes to minus sine. So that's going to be sine of x. All right, so there's my differential. And we want the point here, x equals a half. So we know that y dashed is equal to the sine of pi on 2. Pi on 2, what is the sine of pi on 2? Well, 1. Yeah, now how do we know that? Again, I can draw my unit circle. All right, here is 0, here is pi on 2. Sine is equal to my vertical height. All right, so here is pi on 2. I want the vertical height there, which is equal to 1 for my unit circle. So again, that's 1. And again, there's lots of ways of doing it. You could have done it for your curves. You could have done it for all sorts of different things. So there's my y dashed. Now, knowing that, that is my m of my tangent. Therefore, the m of my normal is going to be minus 1. Why? You're going to reciprocate 1, which is 1, and flip the sign, which is 0. So therefore, I now know my equation of my tangent is given by y minus y1, which is 0. How do I know that? They've given it here. Is equal to m, which is 1, times x minus x1, which is pi on 2. So in which case, y is equal to x minus pi on 2. So that's my tangent. My normal, exactly the same idea. Y minus 0 is equal to, in this situation, minus 1 of x minus pi on 2. And so y is going to be equal to minus x plus pi on 2. And again, I could have used my calculator for this, but these are fairly simple examples. Now I'm going to use my calculator to sort of help here, because after a while it gets a little bit like, Find the equation of the tangent to, let's see what happens here. So we've got y function of x equals x to the power of a third, where x equals 0, the equation of the tangent. So let's do part A first. Y dash is going to be 1/3 of x to the minus 2/3. Yeah, remember, multiply by the power, take one away. Right, so we're now got y dashed is equal to 1/3 at the point where x equals 0, 0 to the power of minus 2/3. Now we have to be careful here, because then we've got y dash becomes equal to 1/3 times 1 on 0 to the 2/3. Now again, why? Because that negative sign there basically means whatever's on the denominator, move it to the numerator. If it's on the numerator, move it to the denominator. And what do we notice here? Well, 0 to the power of anything is 0. 1 divided by 0, not possible. And so in this situation, what we find is y dashed is infinity, or in fact undefined. Where is the one situation where y dashed is going to be is not going to have a gradient? Well, it would suggest here that my gradient is going to be a vertical line. Now, why on earth would that be the case? Well, the great thing is we have Desmos, which I'm going to fire up now to have a quick look at and sketch what this graph looks like. And again, lots of students say to me, well, how am I supposed to know this? Well, there are certain graphs that you must learn, and these are certainly one of them. X to the power of a third is one of them. Well, if there's my value of 0 and I try and take a tangent to that point there, then it is in fact going to be a vertical line. Ooh. So maybe knowing that in advance what that graph looks like could have actually saved me some time. What about f of x? So let's do what, part B now. F of x is equal to x to the power of 2/3. Right, what do we got here? So f dashed of x, which is going to be 2/3 of x to the power minus 1/3. And that's going to be basically 2 on 3 times 1 on x to the power of a third. Do we notice what's going to happen here again? Well, it would appear that if I now try and put x equals 0 into here, 0 to the power of a third is going to be 0. 1 divided by 0 is going to be 0. And so once again, that's going to be 0. How on earth is that going to be possible? Well, I've got my Desmos. Let's have a look. So if I now put in here, what have we got? X to the power of 2/3. There we go. That's the graph we end up with. And again, depending on what exam you're doing and whether you got technology, it might always be a good idea to put this in. And so again, at this point here, we got a huge problem, because actually that point there is not differentiable. Because the question is, how on earth would you draw a tangent to that point? It's simply not possible. And later on in methods, we come up with an idea that, you know, when a graph basically has a kink in it, or we come at it from either side. And again, if you follow the values of the gradient on this left-hand side, yes, what do we notice? They're actually all negative. Yes, and you would argue that they're becoming more and more and more and more negative. Well, if we look at the gradients from this side, they're actually positive. Yes, and you would argue they were becoming sort of more and more positive. At this point here, for it to be differentiable at a point, the values of the gradient coming from one side have to be the same as coming from the other. And that is massive, and it's coming up if it hasn't already come up. So in that situation, it's actually not differentiable at that point in any way, shape, or form. Okay, so interesting to sort of know. Okay, so now what I'm going to do is a couple of VCAA questions. This one came from 2023 paper 2, and I don't want to blow this video out too much by doing too many. But question 5 said, which one of the following functions has a horizontal tangent at 0, 0? Well, I'm sure there are lots of ways of doing it, but it's a Casanable question. So what I'm actually going to do is fire up my calculator. I'm going to go menu, calculus, and I'm going to do tangent line. And basically, remember, it's going to be, and put the first one in x to the power of negative third, comma, x, comma, and we want it 0.0. Right, so it can't be that one. It's undefined. So that's not it. So I'm going to put a cross through that. Now again, just a case of now copying up and doing 1/3, x equals 0. Now again, normally our tangent line gives an equation as y equals 0. What does the line x equals 0 look like? Well, that's a vertical line. Well, that's definitely not a horizontal tangent. Okay, so that's no use to me at all. Why? Well, we already just dealt with that a moment ago, so that's a no. Probably would already have known that if I remembered by this point all of my functions. That's undefined. 2/3 is undefined. What? Oh, let's go back to the next one. Let's change that to 4. 0, that's y equals 0. Y equals 0. That's that. Yes. So at the moment, I'm pretty sure it's going to be that because that's a no and that's a no. But I am actually, because I've got 10 seconds, going to make sure, that's 3 and that's 4. Hit enter and it's undefined. Now, again, if we think about this here, if I differentiate that and take 1 away from that, it's going to give me -1/4. And we can't have x as minus anything, all right? So we could have discounted that straight away. Likewise, that 2/3, take away 1 will give me -1/3, take away 1. So 3 of these we could have discounted just by knowing that this power here will end up being negative, and that's simply not possible. So I'm going to cross out E as my there, and I'm going to say D is my right answer. What about this one? Suppose that a differentiable function, f, which is real, mapped onto real, and its derivative function dash of real mapped onto real, satisfies that f of 4 equals 25 and f dash of 4 equals 15. A lot of people get very confused about what on earth f4 equals 25 means. It is just another way of writing the coordinate 4, 25, right? So being able to interchange between those two, massively important. Determine the gradient, or what about this one? F dash of 4 equals 15. That means the gradient at x equals 4 is 15. It's a positive gradient. Determine the gradient of the tangent line, not the equation, the gradient of the tangent line of y equals that. Now, a lot of this comes down to a little bit of a trick, which I've seen over and over and over and over again. So if we have y is equal to the square root of function of x, you're going to turn around and say, but I don't know what the function is. It doesn't matter. Because what you can now say is y is equal to fx, I'm going to do it in square brackets for the moment, to the power of a half. Well, how do you differentiate? Well, and I'm going to go y dashed is equal to, bring the power down, multiply it by the original function, take 1 off the power, and then multiply it by the differential of the function. All right, so realistically speaking, this is the chain rule. Yeah, and these type of questions I see over and over and over again. Now you're going to turn around and say, well, what does that have to do with the price of fish? Well, if I now change that to f dash of x equals, all right, now I've got to be careful here because of the way that that actually looks. But if I'm now looking for the gradient at 4, I'm looking for f dash to 4. All right, now again, this is slightly bad notation, and I can't really think of a way to do it otherwise, but I've now got a half of f of x. Well, they told me we've got to say, hey, here, f of 4 to the power of negative half times the f dash to 4. Now, again, I don't mean that this is going to cancel, right? That's not the whole point of this. Actually, what I'm going to do is change that to m. Makes life a lot easier. Becomes equal to a half. Do we know what f of 4 is? Well, yes, it told me the f of 4 was 25. So now I've got 1 on the square root of 25, which is 1 on 5. So that's going to be 1 on 5 times by f dash to 4. And we know that the f dash to 4 is 15. So I'm going to cross those through there to give me 3, which is going to give me 3 on 2. And as far as I'm concerned, D is going to be my correct answer. Notice how they mix different topic areas together. We got the tangent of the line, we got the chain rule, we've got fractional indices, all in one question. And there we go. That's the end of this video. Let's just see whether we've done everything. Understand the difference between a tangent and a normal. Yep. Find the gradient of tangent to a curve. Yes. Normal to a curve. Yes. Apply this understanding to a range of questions. Now, I know this video went on, but there is so much in here that is incredibly important that if you now go and practice it, you should be able to smash any question relating to this at all. There is more coming in later videos. Hopefully you will be there watching them with me on, yes, you guessed it, mathsguru.com, where these videos are there and downloadable lesson notes and VCAA questions. If you can subscribe to my YouTube channel, that would be massive. It just sends me a little bit of a signal, say, hey dude, I watched your video. Leave a comment if you thought it was any good, and hopefully I'll see you in another video. If not, please take care and stay safe. Bye-bye.